Hello and welcome back to Calculus 1, section 3.7 on chain rule. The most important section of Calc 1 because about 90 to 95 to 99% of your derivatives will be chain rule. And the chain rule is the way to take the derivative of function composition. So we can write that first. So chain rule is a way to take the derivative of functions rarely come at their vanilla state. You know, just having a sine x. Already, if you have sine 3x, it's a function composition because there is a 3x linear function embedded in sine. Also, e to the 5x. 5x is a linear function embedded into e to the x to create e to the 5x. And then a whole bunch of other things like, let's say, square root of x squared plus 1 and ln of x minus 1 and so on. So technically, you will be seeing way more functions that are composed from two functions and then or three or more to take the derivative than basic functions from today on, which is why this lecture is so important. Before we go and deal with the derivative of function composition, we need to talk about function composition. Function composition. So function composition in this case relates to f of g of x, which is also known as f composed with g of x. So these are the two notations that you guys have seen in the past into f of x. So to have an example here, let's say f of x is equal to sine x and g of x is equal to square root of x plus 1. Well, in this case, f of g of x, meaning f composed with g, is sine of square root of x plus 1. So we are replacing the x of sine with g, so the in-between step would be obviously sine of g, and then g is replaced by x plus 1. So technically you're just plugging things in. We can also calculate g of f of x, and g of f of x would be the square root of sine x plus 1. So now you see that g plays the role of the main, right? And f is plugged inside. Just noticed. Fix that real quick. All right. So now let's take a look at another example. Say that you have f of x supposed to contain a couple of these. So let's say x squared plus 3x minus 6 over x. And g of x is, let's say, cosine x. So now, f composed with g of x is, well, I hope you guys see that the x over here and g of x over here. So just replace each x over here with g, right? That's the way we think about this. So this is technically g squared plus 3g plus 6 over g, if you want to think about it that way. And then you just plug in g, which is cosine squared x plus 3 cosine x minus 6 over cosine x. So we see that every x of f is replaced with g, and we have what that g function is. If we want to go the other way, g of f of x, then that's equal to cosine, and now instead of x, we'll plug in f, which is x squared, plus 3x minus 6 over x. So it's the cosine of the whole thing over there. So this is the basic skill which you guys learned in pre-calculus. And I hope you reviewed this. I did ask you to review this. And when you are looking at this calculation, what you see is simply plug in one function into another. The skill which we need for this class is to decompose functions so that we can take derivative in stages. So decomposing functions. Let's say y equals, right? That's your function. Y equals e to the x squared plus 1. Well, what we need to do here is to break this into what we can now see two basic functions. You see, hopefully, let me just quickly switch this to. So you see e to the x. Do we all see e to the x? It's a basic function. And that would be our f, would be e to the x. And then g, which is the function that plugs into x, is what? Well, whatever I crossed out with x. X squared plus 1. Perfect. So now, if you want to check this, if you take this and plug it in there, you are going to get e to the x squared plus 1. This is the skill that you need to learn. Otherwise, these derivatives are not going to go well at all. This is the only skill you need. Let's take a look at another example. Say you have y equal sine squared x. What are my two functions? F and g. See, the square is on sine, which means that this can be rewritten as this. So this tells us that the main equation is x squared, and the inner one is sine x. So sine x is plugged into, right? Sine x is plugged into the square. Now, if we turn this around, then they're going to be the other way. So y equal sine x squared. Now, the main equation is, this is understood as sine of x squared. So main equation is sine x, which is the outer function f of x. And g of x becomes x squared. So now when you plug in x squared inside the x, you get sine x squared. These two are not the same. The square is on sine, on the other one square is on x. So these are two different functions. These are different functions. So we need to make sure that's clear. I'll write it in blood. Oh, come on. I gotta switch this. Let's take a look at y equals 4e to the x plus 3, let's say. We still have 2, right? What's f? What's g? F is?
Or is it
4e to the x, yes. Very good. Right? So 4e to the x would be the basic one, and then we have x plus 3 for the other one. Y equals, well, this is easy one. What's f was g? What's the square root?
Square root of x f of g. G of x is 1 over x.
You can think of it as the layers of the onion, right, that you peel off one by one. Let's take a look at a spicier case. So how about sine cubed of x squared? Because we can. How many functions do you see on a pile?
3.
3. Very good. We see f, g, and h of x, whatever. So what's the outer function?
Sin x.
X cubed. This can be written as sine x squared everything cubed. So outer one is x cubed. The middle one is sine x. And then all the way inside, x squared. Now, after we start having these that have 3 or 4 layers, I usually get a question, so how do I know every time without making a mistake which one is the top layer, the middle layer, the maybe another middle layer, and then the bottom? And the way is you have to work it out in your head of what is the first thing you would compute, that's your bottom, and then what's the next thing you compute, that's one up, the next thing you will compute, the next one up. So if I had this as sine cubed of, 4 squared, what is the first thing that I would compute? Well, I would compute 4 squared first to get sine cubed of 16. And that is telling me that 4 squared being computed first is this bottom layer. Now, for sine cubed 16, what is the next thing I can compute? Well, it's sine of 16. Now, this 16 is either 16 radians or 16 degrees. So you are going to get a number there, and then you will do the cube at the end, which makes the cube to be the last, the top layer, which is f. So if you are ever staring at the function, not being sure what goes for f, what goes for g, what goes for h, and so on, you can write the function in terms of, whatever number, and you just say, what is the first thing I compute? And that's always your h on the bottom. Y equals square root of e to the x minus 3. How many functions? 3 functions. Perfect. All right, try to decompose this one on your own. We are taking the derivative of this function. We'll take the derivative of all of these examples. And if you are able to decompose them, we're not going to have any issues. So get your FGH. So what's G? E to the x, good. I just want to ask the middle one. So yeah, good. If you had x is equal to 5, the first thing you're going to do is 5 minus 3, right? Which makes x minus 3 on the bottom, and then you have e to the x, the middle, and then you have square root of x on top. So now this x minus 3 goes into x with e, and then e replaces dx under the root, and you have everything under control. Good.
So the f of g of h of x.
Mm-hmm. That, yes. So this would be f of g of h of x. Yes, that's correct. That's when you have 3. Can you have 4? Yes. This is why it's called the chain rule. There is no need, but you can have 15 of these, right? Just because we can, right? So you can put 15. All right, so now y equals x squared plus 6x minus 9. Is there a way to write this one as a function composition? I'm not asking for factoring. I'm asking for function composition. Now, this one is tricky. Clearly, you don't want to do this derivative using chain rule. This is the basic derivative, right? Just 2x plus 6, you're done. But you know that sometimes we flex in mathematics, and that's what this is. So we're going to try and do the function composition for a problem that we absolutely don't have to. It is something from intermediate algebra. You guys learned.
I guess you'd be subtracting 9 first.
Well, would you equal it to 0?
No, that would solve it. That would solve it. So we are not looking to factor. We are not looking to solve the equation. We are looking to rewrite it so that we can do function decomposition. Now, which way can we rewrite? Well, I mean, there's only one way in which you can rewrite this. Since factoring doesn't work, there's only one thing you can do. That's factoring. There are two different, from algebra, there are two different ways to represent the quadratic.
Y equals mx plus b.
No, that's a linear. Quadratic is ax squared plus bx plus c, or what's the other form?
Oh, it's
B plus
it's like b equals plus.
No,
negative b plus or minus.
that's to solve. Nope, that's to solve quadratic.
Is that where you? No, it's a.
No, the one using the vertex.
Is it like something minus b over a?
Nope. That's to calculate the vertex. You could use that to get to what we need.
You're asking me to dig back 20 years.
Completing the square, guys, it's gonna give you the form that has vertex in it. If you complete the square on this one, you get, or you can use the vertex negative b over 2a to calculate vertex, but if you complete the square, you have 6 divided by 2 squared, which is 3 squared, which is 9. So This is y equals x squared plus 6x. Then we add and subtract plus 9, minus 9, and then you still have minus 9 from the problem. And then the first 3 will give you completed square, and that is square root of the first, sine of the second, square root of the third, squared, and then you have minus 18. So now we have f is equal to x squared minus 18, and g is equal to x plus 3. Awesome. Completing the square. I know. It will come back a few times, completing the square, especially in Calc 2 and later on. Not so much for Calc 1, but it's good to, stress about it now because Calc 2 is coming up. So this is what we have. So that's the function decomposition. That's the skill we need to take a look at the function and say, hold on, how many functions do I have on a pile? And to be able to, mentally decompose this. Now we can finally take a look at the chain rule. Chain rule formula, which generally, it looks tough, but the derivative of f of g of x is given as the derivative of f with g still plugged in times the derivative of g. There's another version of this formula which we are going to discuss a little bit later. So now, here we go. One formula that you memorized before is the derivative of e to the 3x. You memorize this as 3e to the 3x. But see, if we follow this formula here, we see that 3x is plugged into e. We know that the derivative of e is e. So we have e to the 3x because derivative of e is itself, and then times the derivative of the exponent, which is 3, giving you 3e to the 3x. And that's that part which is called the chain rule. Now, to explain this, you will understand that this one decomposes into f of x equals e to the x, which is the main, and then g is 3x. To find f prime is e to the x, but we need f prime with g plugged in, and that's e to the 3x. And then the derivative g prime of 3x is just 3. So I hope that you can kind of look at all of this at once, right, and kind of soak it in. So the derivative of e to the x is e to the x. But the formula is requiring, when you take the derivative of f, to have g still plugged in. So my f is e to the x, but I need f prime with g plugged in, which is why it's e to the 3x still. And then g is 3x, and then its derivative is 3. So we have e to the 3x times 3, which is 3e to the 3x. We can do this with trig as well. I mean, we're going to do this with every single function in existence, but what is the derivative of sine of 6x? Well, if you want to decompose this, what's f?
Sine.
sine x. And what's g? G is 6x. So now, the derivative of sine is cosine x, but we need f prime of g, which means it's going to be cosine of 6x. And then g prime is simply 6. So, some students like to do this. In mind's eye, I only see sine of x. So the derivative of sine is cosine, and just put whatever is under the pink x, and then time the derivative of what's under the pink x, which is 6. So it's 6 cosine 6x. And then you get rid of this. It's going to take some time to get used to this mess, but eventually you will get used to this mess. Because this is 90% or 99% of your derivatives. It's going to be this. How about x squared minus 2x to the 9th power? What happened? I can't.
Sorry, is there 3 functions or 2?
2. You have a polynomial raised to the 9th, right? So it's 2. So what's the outer function? X to the 9. So, see, as soon as you know what's the outer function, the f, right? You say, what is the derivative of something to the 9? Something to the 9 is 9 something to the 8. And then you just copy in guts, which is x squared minus 2x, times the derivative of guts, which is what? 2x minus 2. Good. Done. So that's the way the chain rule works. If you want to write the details, sure, that's x to the 9, which will go into 9x to the 8, which we can see up there. And then g is x squared minus 2x, which goes into 2x minus 2. The derivative of square root of x squared plus 3x plus 1. All right, so where do we start?
So you're gonna have your square root, which is gonna change to 1/2 to the quantity of x squared plus 3x plus 1.
Nice. So 1/2 square root of x squared plus 3x plus 1 times,
It's gonna be 2x plus 3.
excellent.
Wait, was it square root? I had it to the quantity. I didn't have a square root underneath there. I thought it was.
Well, we learned before that the derivative of square root of x is 1/2 root x. So we are using the same mold, except now you don't have x, you have this mess. So you are following by the derivative of the mess.
Okay.
Now, we can actually use, let's go other way. You can rewrite the derivative as x squared plus 3x plus 1 to the 1/2. And then do the derivative of the outer, which is going to be 1/2 of what we have inside, right? To the negative 1/2, because you are subtracting 1. 1/2 minus 1 is negative 1/2. Times the derivative of the inside, which is 2x plus 3. That's the chain rule part. And you can simplify this to 2x plus 3 divided by 2 square root of x squared plus 3x plus 1. So here are the two ways in which you can deal with this problem. Obviously, up there in black, put the 2x plus 3 on top, right, times 1. So the answers are going to be exactly the same. So now the upper one, use the shortcut formula for square root of x, but we have square root of f of x, so, I mean, in this case, g of x. So we use the shortcut formula for root x, but you can still do it with the exponents, if you like that better. Okay, what else? For the chain rule, the derivative of cosine of square root of x. Let's see how you're going to work that one out. All right, so what do we have? What's the derivative of cosine? So, and we keep root x plugged in, right? And then times?
1 over 2 root x.
Yes. So, we'll just write this as negative sine root x divided by 2 root x.
Which could be the negative sine over 2.
This root x is buried under sine, and this one is free, so they can't cancel. If you want to think about it this way, you can say sine of root x.
You want us to simplify it on the test?
Well, this is a basic skill. I mean, you will be setting this equal to 0 and solving for values when you go to chapter 4. So the more you simplify now, the reason why I am not screaming about root x in denominator here is because in chapter 4, when you set this equal to 0, you cross multiply, the 2 root x dies. So I am really not stressing with the root x in this case. Just because what's going to happen in chapter 4. You should not leave root 2 in denominator, because that one is definitely irrational. Yes.
I have two questions. So for cosine of square root of x, if you had cosine of 2x, it would be negative 2 sine of 2x.
Yes.
But how come even like this is to a power? So when it's like to a power on the inside, you don't bring
It's not on a power on the inside. It's power is on x. Power is not on cosine.
Right, but I'm saying like since like before, if we had a cosine of 6x or something like that, since it's being
Well, let's write the way you said it. You said it derivative of cosine of 2x.
yes.
That's what you wanted.
Okay.
So, and you said it correctly. Negative 2 sine 2x. Awesome. That's 100% correct. So now what?
So something is being multiplied by x, that's why you brought it out. So in your example, cosine of how I would write it, x to the 1/2 power, since it's a power, we don't bring it out. Like I understand that nothing is
Okay. I see now what your question is. All right, so now we're going to jump here in the blue and write this question as cosine of x to the 1/2. Right? The derivative of cosine is negative sine of x to the 1/2 times the derivative of x to the 1/2, which is 1/2 x to the negative 1/2.
only bring out a value, I guess, for lack of a better word, when in the derivative when it's being multiplied by x. So like ax, I guess we'll call it on the inside.
That's why, well, we memorized that as a formula,
Right.
but now we have chain rule to take care of that. So if you memorized that the derivative of cosine ax is negative a sine ax, it is because of the chain rule. It is. But the reason for it is that a multiplies x, and then the derivative of ax is just a, because the derivative of x is 1, right? Okay, cool. Let's bring some spice.
No.
We haven't had enough spice already.
There is a reason why this is a two-part. The top shelf spice is next class. These are the basic skills here. So we're bringing some spice in, but it's like you put just basic pepper, no jalapeno yet. That's gonna be Wednesday. So let's have sine cubed of 4x. I put the red parentheses to kind of help you out a little bit, because I'm so nice. It's disgusting how nice I am on Mondays.
This is a three-part.
Yes, very good. It's a three-part. Nice. That means you are going to have multiple chains. Awesome. So f of g of h times g of h times h. Right. So this one is different than what we had, because now we have three functions to worry about, which means the answer will have three parts. We have f, g, and h. So what's f?
Sine x.
Gotcha. X cubed, yes, because of that 3. And what's g? Sine x, good. And then what's h? 4x, good. All right. So, the derivative of x cubed, that's going to be 3 blah squared. Now, blah is sine of 4x. Now, the derivative of the inside is, the derivative of sine is cosine of 4x. And then the derivative of 4x is 4. For a total of 12 sine squared 4x cosine 4x.
Yes, I think I got it.
Do you know how there are 9 levels going down? It's about 4.
I think they added an extra one for whoever invented this.
Now, my hope is that you are going to spot 1, 2, 3, 1, 2, 3. That's very important. The number of derivatives, right, will match the number of functions that you have. So if you have 3 nested, you have 3 derivatives on the bottom. So you have your x cubed because you rewrite this as sine 4x everything cubed. That becomes 3 x squared. And then you go down the line. Fair? Right. Let's see what else. Ooh, I forgot about this. Derivative of ln of x squared plus, holy nightmare, this is terrible. I forgot about ln's. It's gonna be like half of your problems. Oh, half. You're going to calc 2. This is like 20% of your calc 2 integration. It's right there.
Okay, that's not so bad.
It's not so bad.
I can live with that.
The derivative of ln is 1 over x.
Yes. Nice. The derivative of ln is 1 over x. Good.
Yeah. So it's 1 over x squared plus 3 times 2x.
Nice. So we have 1 over x squared plus 3 that plays the role of 1 over x. If you say that that's x, right? What's the derivative of ln of x? It's 1 over x. Do we all see that? And then times the derivative of the inside, which is under this pink, which is 2x. So 2x over x squared plus 3. Guys, this gives us a really awesome formula for ln's. I'll write it in blood. The derivative of ln of any function f of x is f prime of x over f of x. You literally go Control C, Control V, and then take the derivative on top. It's very simple. Only E is easier than ln. Put this one on the cloud. You're going to have a lot of these. If you're going to calc 2, you are going to have a lot of stuff that's going to be actually going backwards. So it's important to know this one. Again, whatever the function is, you see how over here the function is copied the same? That's why it says f of x going into the same f of x. So memorizing this particular derivative is whatever the argument of ln is, argument is whatever is inside. When you write sine x, ln x, square root of x, whatever is plugged into these functions, which is these guys, that's called an argument in mathematics for the terminology. So it's derivative of the argument divided by the argument. It's very simple. You have the similar stuff for e to the x. The derivative of e to the f of x is e to the f of x times f prime of x. That's another one of these really cool formulas that you memorize so you don't have to mess with the chain rule or mess with anything else. Whatever the function is, it gets copied times the derivative of that function. This question was on the exam 2 years ago or whatever. The derivative of ln of cosine x. 3 points or 4 points, maybe 4.
1 over cosine x times negative sine x.
Well, maybe 1 over, yeah, 1 over negative sine.
Yes. You can use the formula, the derivative divided by the function, or you can use the chain rule, which is 1 over. So let's do both. So if you're using 1 over x, you're going to go 1 over cosine x times the derivative of cosine x is
Negative
sine x. So the total is negative tangent x. Sine divided by cosine is tangent, right?
Mm-hmm.
If you are using the formula that I presented you up there, right? You copy the denominator, which is cosine x, put its derivative on top, which is sine x, you get tangent x. This is why the formula is the one in the blue cloud is so damn good. You literally copy the function there and you put its derivative on top, and just if you can simplify in one shot. It is really cool to compute the derivative of ln, let's say 6x, which would lead you into ln of any x, right? Any number in front of x. So what happens here? What happened?
1 over 6x.
Keep talking.
Times 6.
Times 6. Chain rule. 1 over 6x times 6 is just 1 over x. And you go, hold on. Isn't it ln of x is 1 over x? How come is also the derivative of ln of ax 1 over x? It's kind of weird, right? Until you realize, using the properties of logs, that this thing here is ln of a plus ln of x. And what's ln of a? What's ln of a? Like ln 6. What is ln 6? Is it a function? No, it's a constant, right? So when you have the derivative of a constant, you get 0 plus 1 over x, and that's why it's 1 over x. So cool. Right? Using the log property to show that. Good. What else? Since I know your trig is your favorite, obviously we're going to pepper in some more trig. How about the derivative of cosecant of e to the 2x? Just because we can. Think about how many functions you have. If you need to decompose them aside, and then try to get the derivative. How many functions?
Three.
3 functions. What's f? No, just what's f without, not derivative. Cosecant x. And what's g? E to the x, and then h? 2x. Okay, great. So now we can start the derivative. You said the derivative of cosecant is negative.
Negative cosecant x tan x.
Great. Which means
Negative cosecant of
e to the 2x, cotangent e to the 2x. So that's the toughest part, right? To kind of use the inner function there. And then times,
2e to the, oh,
well, e to the 2x, and then times 2. Awesome.
would you simplify that, or is it?
Yeah, we're just going to put negative 2e to the 2x cosecant e to the 2x cotangent e to the 2x, and that's it. There's nothing else we can do.
But if you left it in the above format,
For the exam 3, for the exam 2, it really doesn't matter. I mean, it doesn't matter because,
you're still going to be deriving it out eventually.
well, when you say equal to 0, it's only the middle part that can maybe produce an answer. These two don't, so whatever. Now let's write some of the theory here. So if I have the derivative of f of g of h of x that is going to be f prime with g of h of x still plugged in, which is why you had these e's to the 2x show up, because that's the whole parenthesis there. And then times the derivative of g with h of x still plugged in, and finally derivative of h. So if I had f, g, h, 3 functions, I have 3 derivatives that are multiplied going down. So we can box this, but again, what do you do when you have 4? What do you do when you have 5? And they all go down. So it's not a greatest notation. So we come up with a better notation through Leibniz. The derivative of x of f of g of h of x. Let's actually do just 2 first. So g of x. What he says is you take the derivative of f in respect to g and you multiply that with the derivative of g in respect to x. You see, because g is what replaces x in f. So you are taking the derivative of x in respect to g, and you will plug g in instead of plugging in. And now you can see that you are getting the derivative of f in respect to x if these two cancel. You don't cancel them, but if they cancel, right, as fractions, you have df dx, sorry. So now if I have multiple, right, this notation really helps if we have multiple. So f of g of h of x is going to be derivative of f in respect to g. So df dg. And then you have dg dh, and finally dh dx. And you can see that if these guys cancel, you can see that they cancel again to df dx, because this is in df dx. That's what you're looking for, the derivative of function f. Yes, it was more complicated, which is why we have all of the steps in between, but in the end of the day, it's df dx that we're looking for. And no matter how many of these you have inside, right, you will always have df, which is the outer function first, and then the last one here with the dx at the end. So you might have, 5 of these, 6 of these, 10 of these, 20 of these. They all, chain like that. And that's why it's called a chain rule, because you are creating the chain of these going out as many as you have to. So it takes some time to practice this. Obviously, the homework will be available for you guys to practice. This is the part 1, and then we're going to do more practice in the next. So next class, we are going to do second part of this lecture, and then we are going to do the next lesson after that. Bye.